A space-time vortex around Earth, presented by Science at NASA. Would you believe Earth sits in the middle of a space-time vortex? Einstein predicted this almost 100 years ago, and it turns out to be true. On May 4, 2011, researchers announced that NASA's Gravity Probe B spacecraft has detected the vortex, and its shape precisely matches the predictions of Einstein's theory of gravity. The space-time around Earth appears to be distorted, just as general relativity predicts, says Stanford University physicist Francis Everett, principal investigator of the Gravity Probe B mission. Time and space, according to Einstein's theories of relativity, are woven together, forming a four-dimensional fabric called space-time. The mass of Earth dimples this fabric, much like a person sitting in the middle of a trampoline. If Earth were stationary, that would be the end of the story. But our planet spins, and the spin should pull the dimple around in a four-dimensional swirl. This is what Gravity Probe B went into space in 2004 to check. The idea behind the experiment is simple. Imagine trying to spin a toy top on the dimpled surface of that trampoline. It's going to wobble, right? Something similar happens when you try to spin a gyroscope in curved space-time. Its spin axis will drift or precess. Gravity Probe B carried some super-spherical gyros into Earth's orbit to see what they would do. In practice, this simple idea is extremely difficult. According to calculations, the twisted space-time around Earth should cause the axis of the gyros to drift by a tiny amount. Really tiny. It's like measuring the thickness of a sheet of paper held edge-on 100 miles away. Even the slightest disturbance could ruin the experiment. We had to invent whole new technologies to make this possible, says Everett. The Gravity Probe B team developed a drag-free satellite that could brush against Earth's atmosphere without disturbing the gyros. They figured out how to keep Earth's magnetic field from penetrating the spacecraft. And they created a device to measure the spin of a gyro without touching the gyro. Pulling off the experiment was a big challenge. But after a year of data taking and nearly 5 years of analysis, the Gravity Probe B scientists appear to have done it. The gyros precessed, the vortex is real, and we are in it. Einstein was right again. For more information about the space-time vortex and what it means to us on Earth, please visit science.nasa.gov.